In the previous lecture, you explored how data lineage, dataset integrity, training data validation, and secure machine learning pipelines shape the trustworthiness of artificial intelligence systems. Now, you are moving into the next layer of enterprise reality, the artificial intelligence supply chain. When artificial intelligence becomes embedded across enterprise workflows, your models do not exist in isolation. They are built, assembled, packaged, distributed, updated, and deployed through a supply chain of components, tools, and dependencies. If that supply chain is compromised, your model integrity is compromised. This session will help you design supply chain security for artificial intelligence systems with an enterprise blueprint mindset. You will focus on open source model risks, model signing, artifact registry security, and secure continuous integration and continuous delivery pipelines for machine learning. You will also align your thinking to two critical frameworks: supply chain labels for software artifacts and Sigstore. Before you dive into specific controls, let us set the context for why supply chain security has become unavoidable. Enterprises increasingly rely on third-party models, open source libraries, pre-trained checkpoints, container images, and managed services to accelerate artificial intelligence delivery. This means that a significant portion of your artificial intelligence system may originate outside your organization. This is not inherently bad. It is a practical necessity. However, it creates a new reality. You must trust what you did not build. A compromised model can introduce backdoors, biased behavior, data leakage risks, or hidden functionality that is extremely hard to detect through normal testing. Unlike traditional software, the behavior of a model is not fully explained by code review. That is why model integrity becomes a board-level concern. Supply chain risk is not a technical detail. It is a strategic risk. Now that you understand the urgency, let us define what model integrity actually means. Model integrity means that the model you deploy is exactly the model you intended to deploy. It has not been tampered with. It has not been replaced. It has not been modified in transit. It has not been built from unverified sources. It has not been packaged with untrusted dependencies. Model integrity also means that you can prove these statements through evidence. For leaders and architects, model integrity is an assurance capability. It is the ability to answer confidently. Where did this model come from? Who approved it? How was it built? How was it validated? How do you know it has not been altered? If you cannot answer these questions, you cannot claim control. Now let us examine one of the biggest drivers of supply chain exposure: open source models. Open source models are increasingly used for cost efficiency, customization, and local deployment requirements. They also accelerate innovation. However, open source introduces unique risks. You may not know who trained the model. You may not know what data influenced it. You may not know whether sensitive data was included. You may not know whether hidden backdoor behaviors exist. You may not know whether the model has been altered since publication. Even if you trust the model creator, the distribution channel may still be compromised. A malicious actor could publish a Trojanized variant, or a legitimate repository could be altered. From an architecture perspective, the risk is not simply that the model is open source. The risk is that your governance may not extend into the model's origin story. You must treat open source model ingestion as a formal procurement event. It must include verification, provenance checks, testing, and approval. Now that you see the open source challenge, let us move to a foundational control: model signing. Model signing is the practice of cryptographically signing model artifacts so you can verify authenticity and integrity at deployment time. When you sign a model, you create a trust anchor. You can prove that the artifact has not changed since signing. You can detect unauthorized modifications. You can establish accountability for who approved the model. For enterprise architectures, model signing should not be optional. It should be required for any model entering production environments, especially models sourced externally or shared across teams. Model signing also enables policy enforcement. For example, you can enforce that only signed models from approved identities can be deployed to production. This is how you move from trust by assumption to trust by verification. Now that you understand signing, let us look at where signed artifacts typically live. The artifact registry. In modern enterprises, models are stored, versioned, and deployed through registries. These registries may store model files, container images containing model runtimes, dependency packages, configuration bundles. If your registry is compromised, model integrity is compromised. Registry security therefore becomes as important as source code security. You must implement strong authentication and authorization for registry access, least privilege access controls, segmentation between development registries and production registries, immutable storage rules for approved artifacts, audit logging for artifact uploads, downloads, and deletions, approval workflows before promoting a model artifact to production. You must also treat the registry as a sensitive target for attackers. A high-impact attack is not always to break into your production system. It may be to replace the model in your registry so that your next deployment introduces compromise automatically. From a leadership perspective, registry governance is a strategic control point that prevents silent compromise. Now let us connect supply chain security to the pipeline that produces and deploys models. Machine learning delivery pipelines often include data ingestion stages, pre-processing scripts, training runs, evaluation steps, packaging and containerization, publishing to artifact registries, deployment into production environments. This pipeline is effectively the manufacturing line for intelligence. If it is compromised, you may deploy unverified models, poison dependencies, or altered training code. Secure continuous integration and continuous delivery for machine learning therefore requires version control and review for training code and configuration, controlled access to pipeline execution, isolation of build environments, secure secrets management for pipeline credentials, artifact signing integrated into the pipeline, promotion gates requiring approval and testing evidence, separation between development and production environments. From an architectural perspective, you should design the pipeline to produce evidence, not only an artifact. Evidence includes logs, provenance, checksums, signatures, and evaluation results. When pipeline security is strong, you can prove model integrity through auditable records. Now that you understand pipeline security, let us introduce a key framework: supply chain levels for software artifacts. Supply chain levels for software artifacts is a framework designed to strengthen software supply chains. It provides maturity levels that guide how you secure build processes, provenance, and distribution. For artificial intelligence systems, this framework becomes highly relevant because model training and packaging resemble a build pipeline. Applying this framework encourages you to implement controlled build environments, reproducible builds where possible, provenance records that describe how artifacts were produced, isolation of build steps to reduce tampering, policy enforcement to prevent unauthorized artifacts. For leaders and architects, this framework helps you transform supply chain security from vague intention into measurable maturity. You can assess where your organization stands today and define a roadmap. Now that you understand maturity frameworks, let us examine Sigstore, which supports verified signing and provenance. Sigstore provides mechanisms for signing artifacts and verifying signatures, helping organizations build trust in software distribution. In the context of artificial intelligence, Sigstore concepts can support signing model artifacts, verifying that an artifact came from an approved builder identity, publishing provenance information about how the artifact was produced, automating verification during deployment. This reduces reliance on manual trust. It supports scalable assurance. For enterprise architects, Sigstore aligns to the principle that deployment systems should verify integrity automatically rather than relying on human memory or informal process. Now let us ground this discussion with an enterprise scenario. Imagine your organization adopts an open source model for internal document summarization. The model is downloaded, placed in a shared folder, and deployed to a production environment quickly because business teams are eager for results. Weeks later, unusual behavior appears. The model occasionally reveals fragments of sensitive data. It also produces subtle guidance that conflicts with official policy documents. You investigate and discover that the model file was replaced in the shared distribution location. No one noticed because there was no signing, no registry governance, and no provenance verification. This scenario is not a theoretical fear. It reflects the reality of modern supply chain attacks. If you had implemented a controlled artifact registry, signed model artifacts, verified signatures at deployment time, secure pipeline promotion gates, you would have detected tampering immediately. Supply chain security is not about slowing adoption. It is about preventing silent compromise. Now that you understand the architecture controls, let us elevate this to leadership and governance. As a leader, you must establish policies such as no model enters production without verified provenance. No model is deployed without cryptographic signature validation. All model artifacts are stored in controlled registries with audit logging. Open source model ingestion requires formal review and approval. Machine learning delivery pipelines must produce evidence of integrity, not just outputs. This moves your organization from opportunistic adoption to governed adoption. It builds confidence for executives, regulators, and customers. Model integrity becomes a business enabler. Now that you have explored artificial intelligence supply chain risks and integrity controls, let us summarize the most important insights you should carry forward. Artificial intelligence systems rely on supply chains of models, code, dependencies, and pipelines. Open source models accelerate adoption but introduce provenance and integrity risks. Model signing provides a trust anchor that detects tampering. Artifact registry security is critical because registries are central distribution points. Secure continuous integration and continuous delivery for machine learning must include promotion gates, isolation, and evidence generation. Supply chain levels for software artifacts provides a maturity roadmap for securing build and provenance practices. Sigstore supports scalable signing and verification to strengthen provenance assurance. Model integrity is not only technical assurance, it is strategic trust for enterprise adoption. Now that you understand why model integrity and supply chain security define the trustworthiness of artificial intelligence systems, it is time to reflect on your own environment. Are your models stored in controlled registries or shared informally? Are your deployments verifying signatures or trusting artifacts by assumption? Are your machine learning pipelines producing evidence or only producing outputs? If this lecture helped you think like an enterprise artificial intelligence security architect, subscribe to the channel so you do not miss the next sessions. Like this video if you believe supply chain integrity is essential for trustworthy artificial intelligence adoption, and comment below with your perspective. Is your organization ready to enforce model signing and provenance verification, or is adoption still moving faster than governance? Let us build secure, reliable, and trusted artificial intelligence supply chains together.